This is Michelle Joy Arapong, and my discussion is all about testing the difference between two means under dependent samples. So, the t-test was used to compare two sample means when the samples were independent. So, in this topic, a different version of the t-test is explained. This version is used when the samples are dependent. So, when the samples are dependent, samples are considered to be dependent samples when the subjects are paired or matched in some way. And a pre-test and post-test situation, only a gain or lose in values is compared. When the samples are dependent, a special t-test for dependent means is used. This test employs the difference in values of the matched pairs. So the hypotheses are as follows, where MD or mu sub D is the symbol for the expected mean of the differences of the matched pairs. So if it is two-tailed, or HO or null hypothesis is equal to 0. And our alternative hypothesis is not equal to 0. While if it is left-tailed, our alternative hypothesis is lesser than 0. Also, if it is right-tailed, the only thing to be changed is the alternative hypothesis is greater than 0. And as we observe, our null hypothesis is always a statement of equality. So we have here the assumptions for the t-test for two means when the samples are dependent. First, when the samples are random. Second, when the sample data are dependent, of course. Third, when the sample size or sample sizes are less than 30. Take note, it is less than 30 since it is a t-test. And the populations must be normally or approximately normally distributed. So the general procedure in testing the difference between two means of the dependent samples, we have here the steps. So step 1, state the hypothesis and identify the claim. Step 2, find the critical values by locating the intersection of the degree of freedom and the given alpha in table F. So this is our table F. Okay, this is our table F. So, siyang gikat. Then, step 3, compute the test value. So, in finding the test value, it involves several steps. Make a table. So, you have to make a table based on the given data. Find the differences of the values of the pairs of data and place the results in column A. Then, find the mean of the differences using the formula where n is the number of data pairs. So, kana. Then, square the differences and place the results in column B. And this time, you have to complete the table. And afterwards, you have to find the standard deviation of the differences using the formula. Then finally, find the test value using the formula. The formula in the final step follows the basic format of test value is equal to observed value minus the expected value over standard error, where the observed value is the mean of the differences and the expected value or the mu sub D is 0 if the hypothesis is equal to 0. Take note, if the hypothesis is equal to 0. And the standard error of the difference is the standard deviation of the difference divided by the square root of the sample size. Then, both populations must be normally or approximately normally distributed. Since nahuman naman kagkuan sa imuhang test value, let's proceed to step 4. Make the decision whether you have to reject or accept your claim. Then for the last step, step 5, summarize the results. So, to further digest the topic, let us set an example. So, problem number 1, we have here bank deposits. So, a sample of 9 local banks shows their deposits in billions of dollars 3 years ago and their deposits in billions of dollars today. At alpha 0.05, the question is, can it be concluded that the average in deposits for the banks is greater today than it was 3 years ago? So use alpha 0.05. So we have here the data. We have 9 banks, then the data 3 years ago and today. So now let us apply the steps in solving. Step 1, state the hypothesis. Di siya maklaro nino, kay natabunan siya. So, silang kay sa PowerPoint. Pag-open rin sa PowerPoint. So, step 1, state the hypothesis and identify the claim. Since we are interested to see if there has been an increase in deposits, the deposits 3 years ago must be less than the deposits today. Hence, the differences must be significantly less 3 years ago than they are today. So, the mean of the differences must be less than 0. And our claim is our alternative hypothesis. Alright, let's proceed to step 2. Find the critical value. In getting the DF, or known as degrees of freedom, the formula is n-1. Since naman tayo 9 banks, so DF equals 9 minus 1, then the degrees of freedom is 8. Now, we have to locate our DF and alpha 0.05 in table F. So, this is our table F. So, since this is left-tailed, so 1 tail siya na, 1 tail alpha 0.05, 0.05, and our DF is 8. So, we get 1.860. Now, since left-tailed man siya, mag-use tag negative. So, negative 1.860. That is our critical value. Okay, so, for step 3, okay, compute the test value. Taas-taas din step 3. Make a table based on the given data. Okay, you have to input the data 3 years ago and the data today. And after, find the differences and place the results in column A. So, 11.42 minus 16.69, you get negative 5.27. So, the same thing to do sa ibuhang uban nga data until we can get summation of the differences is equal to negative 9.73. Then, find the mean of the differences. So, mean of the differences is equal to summation of the difference over n. So, our summation of the difference is negative 9.73 divided by 9, we get the mean of the difference is equal to negative 1.081. Now, nahuman naman tagwa sa mean of the difference, let's get the square the differences and place the results in column B. So, ato i-square ang differences. Then, after sa pag-square sa differences, atong i-add until we can get the summation of the difference is equal to 40.6958. So, igura siya squared. Now, since we're done getting the mean of the difference and the squared of the difference, now let's complete the table. So, ato na siyang i-input tong ato mga computations. After that, you have to find the standard deviation of the differences. So, we have here the formula. Then, since nanam tayo mga values, let's just automatically substitute its value to the formula until we can get standard deviation is equal to 1.942. So, that is our standard deviation. So, let's find the test value. So, the formula test value, you have here. Then, substitute its value to the formula until we can get test value is equal to negative 1.67. Since we're done getting the test value, let's proceed to step 4. We have to make the decision. So, do not reject the null hypothesis. Why? Since the test value, negative 1.67, is greater than the critical value, negative 1.860, in which the test value does not fall in the critical region. Kaning critical region mo na ang colored region, yung colored yellow. So, do not reject the HO or the null hypothesis. Then, step 5, summarize the results. There is not enough evidence to show that the deposits have increased over the last 3 years. So, the next reporter will give you more examples. That's all for my discussion. Thank you.